So here are our quiz 4 solutions for Math 111. Just the first problem here, we're asked to find the domain of a function, some huge mess of a function. Good news, I guess, is that a lot of it we don't even care about. When you're looking for the domain in this class, you only care about two things. Can't divide by 0. And you can't take the square root of a negative number. Sure, that'll work. Really, you can't take any even root of a negative number. And there's some other things that can cause a function to be undefined, but for our purposes, it's just these two that we're going to run into. So let's see, maybe let's start with this guy. I think it's a little bit easier. Can't take the square root of a negative number. So where do you see square roots here? I guess just this one, right? I'm asking, this function is taking the square root of 10 minus 2x. Note the square root stops right here. So that thing that I'm taking the square root of, 10 minus 2x, can't be a negative number. In other words, it must be greater than or equal to 0. So solve this inequality. It's a linear inequality. So you can solve it almost like you solve an equation. You could subtract 10 from both sides, for example. And then divide both sides by negative 2. Negative 10 divided by negative 2 is positive 5. However, anytime you're solving a linear inequality, if you multiply or divide both sides of the equation by a negative number, you got to remember to flip this sign around. So what I get is that to make sure that I don't take the square root of a negative number, I need x to be less than or equal to 5. Unfortunately, that doesn't finish the problem because I'll still have to make sure I don't divide by 0. So maybe x can't make the denominator, which is the square root of 10 minus 2x plus 1 minus x, can't have an x that makes this true. Because if it makes this true, that x will make me divide by 0, so it can't be in the domain. So how do you solve this? Well, we've seen things like this. This is a this is a radical equation, because you got the square root sign here. So the way you solve these is you get rid of the radical, you isolate it. So to isolate things, I'm going to add x to both sides of the equation and subtract 1 from both sides of the equation to get me here. Now I'm going to square both sides of the equation. The square root and the square cancel out, and over on this side I got x squared minus 2x plus 1. Now I got a quadratic equation, so I can solve this thing. I could solve it by setting it equal to 0. So maybe add 2x to both sides and subtract 10 from both sides. And I would get x squared minus 2x plus 2x. I cancels out all those x's. And then 1 minus 10 gives me negative 9 equals 0. So x is equal to plus or minus 3. Either because you add 9 to both sides and then take the square root, or you factor this as x plus 3 times x minus 3. Anyways, you get these two solutions. Are they both solutions? Well, I don't know. We should probably check. So maybe I write that. So x equals 3 or x equals negative 3. But anytime you have a radical equation, you want to check your solutions to make sure that they both in fact work. If x equals 3, 10 minus 6 is 4. Square root of 4 is 2. 2 plus 1 is 3. Minus 3 is 0. Yeah, it looks like this one over here works. What about negative 3? Well, if x is negative 3, I got 10 minus negative 6. In other words, 10 plus 6. That's 16. Square root of 16 is 4. Plus 1 is 5. 5 minus negative 3 is 5 plus 3, which is 8, not 0. So this is not a solution. So the only solution is 3. And now remember what you were solving. You were trying to find the numbers that made you divide by 0. So I don't want 3 in the domain. So what I'm saying is x is all numbers, maybe I should graph them, less than or equal to 5. So all this stuff over here. Oh, except you don't want 3. So it's all this stuff, and it's all this stuff. How do you write that in interval notation? You say your domain is everything from negative infinity up to 3. Union, everything up from 3 up to 5, but note I do want to include 5, but not the 3. This right here would be my final answer to this first problem, which maybe should be worth more than 6 points because that was a lot of work. Number 2, given a function asked to evaluate g of -1. All you need to know is that g of -1 is what you get when you change all the x's into -1s. So it's 4 minus 23 minus 7, which is the same as 4 minus 30, which is -26. That's the answer. Really, the biggest challenge with that problem is just understanding what is being asked, what g of -1 means. And knowing that it's different from all values of x so that g of x equals -1. This and this look similar, they're different. This one is saying that thing you have, that 4x squared plus 23x minus 7, what would x have to be? What would the input have to be to make this thing equal to -1? Well, this looks like a quadratic equation, so I can solve this by, I guess I have a few options. I can hope it factors. I didn't say that it didn't factor, so hopefully it factors. If I want to factor, it only helps to factor if my equation is set equal to 0. So let's add 1 to both sides of the equation to get 4x squared plus 23x minus 6 equals 0. Then we'll try to find two numbers that add to 23 and multiply to -24. Two numbers that will do that are positive 24 and -1. So if I replace the positive 23x with those two numbers, positive 24x and -1x, I will have rewritten this in a form that can factor by grouping. You might have other ways of factoring this, and that's totally fine. I'm just showing you an alternative method of how to factor when your leading coefficient is not a 1. So you have this factor by grouping. Look at these first two terms. They have a 4x in common. Pull out that 4x, and you're left with x plus 6. X plus 6 becomes your target. You want to pull something out from over here so that you'll be left with x plus 6. The only thing that'll do that is a -1. What you now have are two terms, and they both have an x plus 6 in them. So you can pull out that x plus 6. If you did, all you'd have left is a 4x and a -1. You've now factored. You got something times something equals 0. That can only happen if one of those two things equals 0. So set them both equal to 0 and solve. Get two solutions. You can check your answers if you feel like it, but you don't need to over here because there's no information lost in this solving process. Get your answers, call it good, and move on. Finally, number 3, sketch a graph. So this is a piecewise linear function. So what happens is this machine does something different if I input numbers less than -2 than what it does when I input numbers that are greater than or equal to -2. So specifically, it does this thing when I input numbers that are less than -2, and it does this thing when I input numbers that are greater than or equal to -2. So over here to the left of -2, I want a graph of 2x plus 5. Well, 2x plus 5, it's linear. The y-intercept is a 5 and the slope is a 2, meaning it goes through this point, and then every time it goes up by 2, it goes over by 1. Okay, I'm going to write this better. 2x plus 5. 5 is my y-intercept. 2 over 1 is my slope. So if I start at this 5 right here, I go up 2 and over 1. Up 2 and over 1 and get some sort of a graph. However, I only want to draw that graph if x is less than -2. So here's where x is less than -2, so I want to start drawing it here. So if you work backwards, what you'll see is that this point is on the graph. How do I know this point is on the graph? Well, try it. If this point is on the graph, you go up by 2 and over 1. Do that again, up 2 over 1, and you'll end up at your y-intercept of 5. So this point is on the graph, and because the slope is 2, I know that this point is also on the graph. So what I'm going to do is draw a line that connects those as best I can. Call that good. Note this circle is open because if I put -2 into this machine, I don't use this rule. I only use this rule when x is less than -2. If I put in -2, I'd use this rule, 1 minus 2x. And so 1 minus 2x, maybe in a different color, I could rewrite as -2x plus 1. Let's do that better. Maybe this should say y equals 2x plus 5. And this says y equals 1 minus 2x, which I can rewrite as negative 2x plus 1, which is saying that I have 1 for my y-intercept, and negative 2 divided by 1 is my slope. So, saying that my y-intercept is 1, this point right here should be on my graph. And then I go down by 2 every time I go over by 1. So this point should be on my graph, this point should be on my graph, this point should be on my graph. What about in this direction? This point should be on my graph, this point should be on my graph. You might think you should keep going, but you don't want to keep going, both because you run out of graph and because it only follows this rule if x is greater than or equal to negative 2. Here's where x is negative 2. So if it's equal to negative 2, I want it to follow that guy. And then I'll try my best to draw a line that goes through the rest of those dots. It's very difficult to do on a computer, but I'll call that good enough. This right here is my graph. It's the answer to the question. So I'll stop this video here.